So I'm turning the recording. Yeah, I just turn on the record. Okay. While working on this, just a couple things about kind of quiz. Okay, so quiz tonight I'll turn on at 9 o'clock. Okay, until the 11:55, 59. Okay, and you can choose any 30 minutes here during this time slot. Okay, so my suggestion kind of bring a mouse. Okay, use mouse. Okay, because you have to draw structure. And show the mechanism. Okay, so draw the curved arrow. Okay, so in this case, the mouse is better than kind of the pad. Okay, and for those of you kind of ask for the extended time. Okay, so because of some kind of the disability kind of the office letter. Okay, so please email me your start time. Okay, so what time do you want to start your quiz? Okay, the reason for that kind of only after you start your quiz, okay, there's generate some kind of student report, okay, and then I can adjust you the quiz time, okay, so give you some actual time, okay, so so far there's kind of no student record and nothing, okay, there, okay, I cannot do anything, okay, so just please email me kind of your start time, okay, so if you need some kind of actual time, okay, so because of the disability kind of the report, okay, all right. Okay, so for this reaction, okay. So remember, okay, so chapter 9 we talk about all about kind of elimination reaction, okay. Elimination reactions, okay. So E2 reaction we so far talked, okay. So one thing is kind of the residual selectivity of elimination reactions, okay. E2 reactions, okay. So if you have more than one kind of the beta hydrogens, okay, you have to determine kind of which beta hydrogen live with kind of the group, where do you build up kind of the CT amount, okay. So for this guy, there are kind of the two kind of the beta hydrogen, okay, one's here, okay. So that means kind of you either eliminate this hydrogen, this bromide, generate kind of double bond between these two carbons, okay. So that's one product, okay. Oh you eliminate kind of bromide and those hydrogen, okay. So between these two carbons, alpha carbon, okay, beta carbon, okay, and then you generate kind of another product, okay. Okay, so that's the come kind of important about the residual selectivity of E2 reaction, okay. Then safe, okay. So normally you want to get the more substitute kind of alkene as product, okay, because that's more stable, okay. And then for this case, okay, so more stable ones kind of this one, okay, because this one has kind of 3 alkyl group, okay, 1, 2, 3, okay, and this one only has 1, okay, so that's the most stable one, okay, all right. So that's about kind of a little bit left over from the last week, okay. Right, and also there are some kind of exception, okay, for this kind of Zaintsif rule, okay, and called kind of Hofmann rule, okay. So that's kind of totally opposite, okay, from kind of the Zaintsif rule, okay. So when you do the E2 elimination, okay. Right. So for Hofmann rule, okay, actually get kind of the last substitute alkene, okay, the C1, okay. Okay, last substitute alkene, okay. So remember the Zaintsif rule, okay. So right down, probably still here, okay. You get more substitute alkene, okay. Okay, so the example here, okay. But most time follow kind of Zaintsif, okay. But there are kind of 3 special situations, okay, follow kind of the Hofmann rule, okay. The first one kind of if you have the tertiary amine as the group, okay. Just write down here, okay. Tertiary amine as the group, okay. And then if you apply some base, okay, so actually generate kind of last substitute alkene, okay. So the example showed here, okay. So for here, okay, so that's link group is tertiary amine, okay. So and then there kind of this alpha carbon and you have kind of two beta hydrogens, okay, one's here and one's here, okay. So theoretically speaking, kind of you should generate kind of the more substitute alkene, okay, between these two carbons, okay. But for the reality, okay, you just kind of generate last substitute alkene, okay. So the terminal alkene, okay. The reason for that is kind of normally speaking, this tertiary amine is kind of very bulky, and then no totally block the base attack kind of beta internal beta hydrogens, okay. But for terminal, the beta hydrogens, okay, so because kind of external, okay, last steric hindrance, okay, and then easy to attack by kind of the base, okay. Another reason kind of normally speaking, kind of the terminal hydrogens a little bit acidic compared with the internal hydrogens, okay. And for you guys, just remember, okay, so if the tertiary amine as the link group, okay, so you generally kind of the Hofmann elimination product, okay, and the last substitute alkene, okay. So that's the first situation, okay. So tertiary amine at the link group, okay. All right. And then second kind of exception is kind of you have very bulky base, okay. So example showed here, okay. So we have this bromide, okay. So if we use kind of small regular base, okay. So like this ethoxide, okay. So follow Zaitsev rule, okay. So major products should have kind of alkene with more substituent group, okay, here, okay. But minor is kind of Hofmann elimination product. But if we increase the base size, okay. So for example, if we use kind of therapeutic side, okay. So this guy, okay. And then because they are steric hindrance, okay, so not easy access kind of internal beta hydrogen, okay, internal beta hydrogen here, okay, but no problem can access to kind of terminal beta hydrogens, okay. So in this case, the Hofmann product will become a major product, okay. So last substitute alkene, okay, and then the scientific product become the minor product, okay. And if we further increase the base size, okay, so this guy, okay, I don't know what's the name for this one, base, okay. Very bulky one, okay. So and then you can see kind of now the kind of Hofmann product, last substitute alkene kind of become dominant, okay. So 92%, okay. So very tiny amount kind of Zaitsev product, okay. And another bulky base here you need to remember is kind of the triethylamine, okay, TA, okay. So the T is kind of tri, okay, ethyl, okay, and amine, triethylamine, okay, that's structure, okay. So normally speaking, okay, for this kind of bulky base, okay, so will be kind of the very good base, but cannot work at the nucleophile because kind of too bulky, cannot kind of do substitution reaction, okay. So that's something please keep in mind, okay. Yeah, and give you guys another example, okay. All right. Okay, so we have kind of this 2-bromo butene as kind of substrate, okay, react with the T-butyroxide, okay, all right. So in this case, because T-butyroxide kind of too bulky, okay. So the major product should be kind of terminal alkene, okay. So last substitute, okay. So this is the major, and then plus the minor should be kind of internal alkene, okay. Right, and for the exam quiz, okay, so keep in mind, okay, so you only need to draw kind of major product, don't need to draw kind of the internal one, okay. Right, and then last kind of the exception kind of the conjugation effect, okay. So conjugation effect kind of happen kind of if you generate kind of double bond can conjugate with some other pi bond system, okay, and then that's maybe kind of follow Hofmann rule instead of not follow kind of the kind of Zaitsev rule, okay. So conjugation effect, okay. So here I just kind of give you one example, you know what's going on, okay. So we have benzene, okay. All right, so just kind of here, need to be the move up. All right, so here's the leaving group, okay, and then you want to do kind of elimination, okay. So for example, we just use kind of methoxide as kind of base, okay. All right, and then there are kind of two beta hydrogens, okay. So one's here, okay, one's here, okay. So theoretically speaking, okay, so if we follow kind of Then safe rule, okay, so we should get kind of a more substitute alkene, okay. Yeah, so that should be kind of major, okay, because they have kind of the four the alkyl group, okay, surround the kind of the CZ bond, okay. But the reality, okay, this is a major product, okay. Okay. Right. So this one has kind of two substitute group. Why this one's major? Okay, so reason for that kind of the conform conjugation. Okay, conjugation. Remember in the organic chapter 1, I said kind of the double bond, single bond, double bond, single bond, can you kind of alternating way. Okay, and so if you more conjugation, you have kind of lower energy and more stable product. Okay. And here, okay, so you can this double bond can form conjugation with kind of the benzene ring. Benzene ring has kind of huge pi bond system. Okay, so that's making it kind of more stable. Okay. But here, okay, so this product, okay, so because they're kind of sp3 hybridized carbon, okay, break up the conjugation, okay, so that's normal stabilization. It's kind of isolate kind of two pi bond system, okay. So that's the reason for that, okay. And for you guys, just keep in mind, these three situations, okay. So when you draw the kind of the E2 elimination product, okay. So if you kind of tertiary amine or kind of the ethylene group or kind of bulky base, okay, so you're just kind of Hoffman product, okay, so that's last substitute alkene, okay. So if it's kind of you possibility just kind of the conjugate system, okay, so there's maybe also possibility for just kind of the Hoffman product, okay. All right, so that's the about kind of E2 elimination, okay. Just keep in mind, if you have any questions, okay, please type in the chat window, okay. Okay, that's good question, okay. So bulky base, okay, so so far you only need to remember two, okay. So one is the T-butyl and also the triamine, okay. So these two, okay. Probably in the later chapters, okay, there's another one, actually kind of maybe later this, called kind of LDA, okay. So that's all three, okay. These all three, okay. So whenever you see these three, okay, that means kind of the Hoffman elimination, okay. So all other base will be kind of full of safe, okay. So all other, okay. All right, okay. So now we done kind of the E2 elimination, okay. So we move to the E1 elimination, okay. So E1 elimination we can learn this one compared with the S1 reactions, okay. So E1 elimination normally happen kind of we call it unimolecular elimination, okay. So that's why kind of E1, okay, because the reaction rate loss, like this, okay. Only involve kind of substrate, okay. So and has nothing to do with kind of base, okay. And also for the E1 elimination, okay, so normally only weak base, weak nucleophile can do the work, okay. So like normally speaking, kind of just some neutral molecule like water, methanol, ethanol, some kind of alcohol, okay. So not require kind of a strong base, okay. And so E1 elimination similar like the S1 reaction, kind of two-step reaction, okay. So you have to kick off the group, okay, and then those kind of the weak base coming in kind of pick up the group, okay. So maybe show you guys some kind of mechanism for the E1 elimination, okay. Right. Okay. So we have this substrate case, so that material touch on these two full bond, okay. So alpha carbon has a link group, and then beta carbon has kind of the hydrogens, okay. So normally speaking, kind of the E1 elimination, the base is kind of too weak, okay, cannot grab the beta hydrogens, okay. So in this case, you have to kick off the link group first, okay. And then you try to kind of somehow kind of the carbon cation, okay. Okay, and then at this stage, okay, so the base coming, okay. So normally base is kind of a neutral molecule, okay, so it's kind of use B represent, okay. So because you generally kind of carbon cation, little bit hard kind of push away this here the hydrogen, okay. And then that's the big base pick up this hydrogen, and then the actual share between alpha beta carbon and also beta hydrogen shift to here, okay. And then give you kind of a final product, okay. okay, and then sorry. Okay, and then yeah, you also get kind of HB. That's linked to be the positive charge here. Okay, and then the link group. Okay, negative charge. Okay, all right. So yeah. So yeah, the last issue about kind of the even emission kind of normally the coexist with kind of S1 reactions. Okay, so if you take second look at kind of the for E1 emission, the first step is actually exactly same as kind of S1 reactions. Okay, so kick off link group, then kind of carbon cation. Okay, and only difference is kind of the for S1 reactions. Okay, so the nucleophile will come in. Okay. Kind of the attack kind of the carbon cation, and then you generate kind of final product. Okay. But for the E1 reaction, okay, so your base pick up a beta hydrogen, okay, and then give kind of the alkene, okay. So that's the only difference, okay. But because these two kind of the two similar, okay, so that's the normally speaking, you actually kind of generate mixture, okay, has both the elimination product and also the substitution product, okay. Yeah, so that's showed here. Okay, normally speaking, kind of under the same reaction conditions. Okay, so remember the E1 elimination. Okay, so S1 reaction can weak base, weak nucleophile. Okay, so normally under these conditions. Okay, so the major production kind of S1 product, but you always get kind of some E1 product. Okay, so yeah. Yeah, so here's kind of showed you some kind of real examples. Okay, so by draw the kind of mechanism. Okay, kick off the link group. Okay, then the carbon cation. Okay, the first step. Okay, similar as kind of S1 reaction, kind of rate determining step. Okay, so that's slow step. Okay, so that's why the E1 reactions rate law okay only have kind of substrate. Okay, has nothing to do with kind of base. Okay, because the base kind of second step. Okay. Right. So now the base come in, okay. So weak base water, okay. So pick up kind of the beta hydrogens, okay, and then give you kind of the alkene, okay. And for the energy diagram, okay. So it's very similar to the S1 reactions, okay. So actually same step, first step, okay. And the carbon cation as kind of intermediate, okay. And so also redetermine stack. Only difference kind of second step, okay. Second step, okay. So E1 emission, okay. So normally has kind of a little bit higher energy barrier, okay. So that's why kind of last the minor product, okay. And the S1 product, okay. So kind of has a lower energy transition state, okay. So it has kind of the major product, okay. And here I show you guys the one video, okay. So where is it here? Show the whole process of the E1 elimination, okay. Yeah, pretty good one, okay. So because this one also showed you the energy diagram at the same time, okay. All right. So this is the substrate, okay. It's bromide, okay. All right. So now the first step, okay. Kick off the link group, okay. Okay. So now the bromide is gone, okay. You can see generate kind of the tertiary carbon cation intermediate, okay. So triangular planar, okay. Right, so now the base come in, the base kind of ethanol, okay, very weak one, okay, and take up one beta hydrogens, okay, and then you build up the bond between the alpha carbon, beta carbons, okay, so the alkene, okay, so that's the so that's some kind of animation for the E1 elimination, okay. All right, okay. So now, we still need to talk about kind of the radiochemistry and also stereochemistry of E1 elimination. Okay. For the radiochemistry, okay, so E1 elimination actually kind of same as kind of the E2 elimination. Okay, so the still follow the Zaitsev rule. Okay. So here's one example. Okay, so okay, so you have kind of this the alcohol, okay, try to do the E1 elimination, okay, so use kind of E1 elimination normally speaking kind of use neutral condition or kind of acidic condition, okay. and then yeah, generate kind of yeah more substitute alkene. Okay, so last substitute alkene as kind of yeah the minor product. Okay, so that's yeah pretty easy. Okay, so yeah, follow kind of yeah the yeah Zaitsev rule. Okay. And for the stereochemistry, okay, so yeah, actually kind of also similar to the isomer reactions, okay, so yeah, because yeah, you generate kind of carbon cation intermediate, okay, so in this case, okay, so yeah, stereochemistry kind of randomized, okay, so you don't need do the kind of the anti-coplanar emission, okay, so remember talking kind of last week, okay, so yeah, for the E2 emission, okay. So the leaving group and also beta hydrogen kind of has to be kind of anti-coplanar, okay? So that's the base can come in kind of just the one shot, okay? Get everything done, okay? So one step, okay? And for the E2 emission, the E1 emission, okay, so there's no such requirement, okay? So yeah, and as well as there are kind of beta hydrogens, okay, that you can do E1 emission, okay? So in this case, yeah, even you have kind of the chiral static material, okay? So yeah, for example, this is kind of this example, yeah, this molecule I showed in kind of in the E1, E2 emission, okay? So yeah, 1, 2 diphenyl bromo propane, okay? And so if we do the E1 E2 emission, okay, so depending on what's kind of the chiral center assignment for these two chiral carbons, okay, we just kind of one specific alkene, okay, E or Z, okay. But for the E1 elimination, okay, so you're generally kind of both product, okay, so E and Z, okay. What's SM? Oh yeah, SM kind of starting material, okay. Second double E1 elimination, the hydrogen bond. Yeah, that's right, okay. So the second step, okay, so you break up the hydrogen carbon bond and then form a double bond, yeah, pretty much that's the same step simultaneously, okay, so yeah. All right, okay, so let's little bit the follow kind of the stereochemistry of the E1, okay, so yeah, just keep in mind even you start with kind of one stereo isomer of your starting material, okay, so eventually very likely you get kind of both cis trans kind of isomers, okay. And here's showed you what's going on, okay. All right, and so that's the actual kind of the same compound as showed here, okay. So it shows you kind of varied structures, okay. All right, so if you do E1 animation, you kick off the link group, okay, and then you generate kind of carbon cation, okay. So the lifetime for the carbon cation, okay, just kind of pretty long, okay. So in this case, if you don't do any kind of bond rotation change, okay, so it directly take up kind of beta hydrogens, okay, you generate kind of probably this trans, okay, okay. But because the lifetime for this carbon cation is pretty long, okay, so you can do quickly rotation, okay. So the bond, okay, so this here the alpha carbon beta carbon bond, okay, and then base coming take up kind of beta hydrogens, okay, and then eventually you generate kind of cis, okay, so alkene, okay. So all in all, okay, you generate kind of mixture both the E and the Z, okay, cis and trans, okay. So that's something keep in mind, okay. So E1 emission, the possibility you generate kind of both cis and trans alkene, okay. All right, and then remember also E2 emission, okay. So I said kind of for cyclohexene kind of derivatives, okay, has to be kind of kind of trans-diaxial elimination, okay, trans-diaxial elimination, okay. But no such requirement for the E1 elimination, okay. So other kind of beta hydrogen, you can do kind of E1 elimination, okay. So example, I give you guys here, okay. So this one, okay. All right. So for this compound, okay, so if we want to do the E2 elimination, okay, and for example, with some kind of strong base, okay, so the sodium hydroxide, okay. All right, so you cannot kind of do elimination between this hydrogen and also this chloride, okay, so these two guys, okay, because these two both kind of wedge bond, okay, that means kind of same pointing, okay, cannot reach anti-positions, okay, no matter how do you do ring flip, okay. And only possibility kind of you can do elimination kind of between beta hydrogen here, okay, and then with the chloride, okay. So yeah, in this case, yeah, if you do E2 elimination, okay, 100% you get kind of this product, okay. 100%, okay. So because this hydrogen cannot gone, okay, cannot leave, okay. But if you use same substrate, okay, and then do the kind of E1 emission, okay, so yeah, you actually kind of major product kind of still do the same thing, okay. All right, so E1 emission, okay, for example, and then you can do the emission, no problem, okay. Actually, kind of preferred, okay. So because this one can give kind of more substitute arcing, okay. Yeah. And so that's the major, okay, and then there's kind of maybe minor, okay. Yeah, here's the minor, okay. So because this one actually kind of last substitute arcing, this is kind of most substitute arcing, okay, 3 arcyl group, okay. So that's actually follow the safe rule, okay. So that's preferred, okay. But you cannot generate this product from kind of E2, okay, because E2 had full kind of anti-coplanar emission, okay. So that's something you can keep in mind, okay. All right, okay. So, but there's one big issue with kind of E1 emission, okay. So that's rearrangement, okay. So because E1 emission same as kind of the S1 reactions, okay, you generate kind of carbon-cation intermediate, okay. So remember in the class I said, okay, so as long as you generate kind of carbon-cation intermediate, okay, there will be possibility for arrangement, okay. So last year this E1 emission is the second reaction kind of carbon-cation arrangement, okay. So later we maybe learn like 2 more, okay. So yeah. All right, so yeah, example showed here, okay. So we try to do the E1 elimination for this substrate, okay. So yeah, that's kind of link group, okay, and then there's kind of no beta hydrogens here, but there's kind of 1 beta hydrogen here, okay. So suppose you build double bond between this carbon and also this carbon, but the reality, okay, so looks like some kind of magic happened, okay. So the double bond built up between this carbon and this carbon, okay. So on the right, okay, and then there's 1 methyl group kind of disappeared from the middle carbon and then put on kind of here, okay. So that kind of the link group side, okay. So that's actually kind of rearrangement happened, okay. So that's also kind of one of the difficult part for this chapter, okay. So overall mechanism actually show you guys here, okay. So pretty much the first step kick off the link group, okay, generate kind of carbon cation, okay, and then that's the secondary carbon cation here, okay, second carbon cation here. Remember, okay, so once you generate kind of carbon cation, you need careful, okay, so yeah, look around, okay, so yeah, is there any kind of tertiary carbon or kind of quaternary carbon around this the secondary carbon cation, okay. So there's kind of this is quaternary carbon, okay. So that means kind of you can have 1, 2 arcyl shift, okay. So this whole methyl group, okay, shift to here, okay. And then you generate kind of more stable kind of tertiary carbon cation. That's this guy, okay. And then the base, okay, so weak base, okay, so that's water coming, okay, pick up the hydrogen, okay, and then you shift the electrons, okay, so the two here, okay, that's build up kind of this arcing, okay. So that's the whole process, okay. And then I can give you guys kind of one more example, okay, so the very similar kind of very similar, okay. Yeah. Right. So for this one, okay, so we also want to do kind of the E1 elimination, okay, and then for the reality, we're trying to kind of the product something like this, okay. Okay. So that looks like some kind of the methyl group shift, okay. So what happens kind of the similar thing, okay. So the kick off the link group, okay. You generate kind of secondary carbon cation here, okay. So this one's kind of next kind of quaternary carbon, okay. So that's you can do 1, 2 arcyl shift, whole methyl group, okay, shift to these carbons, okay, and then you generate kind of the more stable kind of tertiary carbon cation. Okay, right. So no methyl groups here. Okay, maybe label you guys can a little bit different color. Okay, so this is the methyl group now is shifted here. Okay, all right, and then we have kind of carbon cation on this carbon. Okay, okay. So now we can do elimination. Okay, so some weak base, water coming, okay, pick up this hydrogen, and then electron shift between these two carbons. Okay, you can find out for that. Okay. So for the rearrangement, okay, just a little bit careful. Okay, so good thing kind of no rearrangement for the SN2 and those E2 reactions. Okay, so because those two won't involve any kind of some kind of carbon-cation intermediate. Okay. All right. Here's kind of a little bit the summary of the E1 and also E2 elimination. Okay. So for the E1 elimination, okay, keep in mind, okay, so just kind of the unimolecular kind of reaction mechanism. Okay, so only the reaction rate okay, involve kind of the substrate. Okay, but for the E2 elimination, okay, involve both substrate and those the base. Okay, so similar like SN2 reaction. SN2 reaction kind of nucleophile and also substrate. Okay. Right, and then second kind of the preference of the substrate. Okay, so that's actually I didn't mention in the class. Okay, so for the E1 elimination, okay, so prefer kind of tertiary followed by secondary, and then no E1 elimination for the kind of primary. Okay, so that's exactly same as kind of SN1 reactions. Okay, so reason is kind of stability of carbon cation. Okay, so the same as kind of SN1 reactions. Okay, so tertiary carbon cation more stable followed by kind of secondary. Okay, and then primary carbon cation normally speaking won't exist in kind of solution. Okay, so that's the why is kind of not preferable for E1 reaction. For the E2 reaction, actually kind of very interesting. Okay, also follow kind of same kind of order. Okay, so tertiary and then followed by secondary and then followed by primary. Okay, so that's the reason for that kind of stereo hindrance. Okay, so the E2 want to take up kind of beta hydrogens. Okay, so if you kind of tertiary one, okay, so want access to kind of the middle the alpha carbons. Okay, only pick up some kind of the extend out kind of beta hydrogens. Okay, and then followed by secondary and tertiary primary. Okay, primary kind of the E2 will compete with kind of SN2 reactions. Okay, so that's why the E2 prefer kind of tertiary, secondary, and primary. Okay, and then for the E1 reactions. Okay, so normally you use kind of weak base. Okay, so normally speaking kind of neutral molecule like water or kind of ethanol, methanol. Okay, so some kind of solvent. Okay, E2 reaction requires strong base. Okay, strong base. Okay, so if you want to do E2 reaction, you have to use kind of strong base. Okay, so that's something to keep in mind. Okay, all right, and then for the solvent. Okay, so that's I also didn't mention in the class. Okay, so for the E1 reaction, okay, prefer polar protic solvent. Okay, so same as kind of SN1 reactions. Okay, so reason for that, the polar protic solvent can stabilize kind of carbon cation onto the lead group. Okay, lower the kind of energy barrier. Okay, and for the E2 reaction, pretty interesting. Okay, so it doesn't matter. Okay, so so solvent polarity not important. Okay, so E2 reaction actually you can do kind of in the polar protic solvent and the polar aprotic solvent, even kind of the non-polar solvent. Okay, so E2 reaction has nothing to do with kind of has a kind of last the effect with kind of the polarity of solvent. Okay. And the stereochemistry, okay, so the both E1 and E2 prefer kind of safe the product, okay, more substitute arcane. Okay. And the E2 keep in mind, okay, so are kind of three exceptions, okay, for the Hoffman elimination. Okay, so tertiary amine ethylene group. Okay, and then more bulky base and also conjugations. Okay, and so for the E1 that's regional selectivity. Sorry. For stereo selectivity, E1 reaction no stereo selectivity. Okay, but for the E2 reaction, okay, follow anti-coplanar elimination. Okay, follow anti-coplanar elimination. Okay, so that's okay. All right, okay, so that's come kind of a little bit the most important part. Okay, for the today's class. Okay, so something kind of said. Okay, so I get kind of confused. Okay, so already kind of we learned about kind of substitution reaction SN1 and also the SN2 and E1 E2. Okay, so now we have to learn some kind of E1 E2. Okay, how do we determine kind of SN1 or SN2 or kind of E1 or E2? Okay, so we kind of before that, okay, we need to be talk about base strength. Okay, for the E2 reactions. Okay, so require kind of strong base. Okay, you can see here. Okay, so with increased kind of the base city. Okay, so it's kind of also increase kind of conjugated acid kind of pKa, okay, it got kind of higher reaction rate, okay, and then for the E1 reaction has nothing to do with kind of basicity, okay. So now we move here, okay. So how do we determine kind of the SN1 reaction, SN2 reaction, or E1 reaction, or E2 reaction? Okay. So in the future exam quiz, okay, for the quiz tonight, okay, so it will be safe, okay, or a substitution reaction, you only need to determine SN1 or SN2 reactions, okay. But for the exam 1 or kind of quiz 2, you have to determine what's these reactions, okay, SN1 or E1 or E2, okay. Right, so the first thing you need to look at kind of the nucleus, okay, and also base, okay. That's the first thing you need to look at, okay. So there are kind of four the category, okay. So one is kind of the strong base but weak nucleophile, strong nucleophile but the weak base, okay. So for this the slide you don't need to record, okay. I will give you kind of summary tables, okay. So don't record it, okay. So so if you are you find this species kind of strong base but weak nucleophile, strong nucleophile but a weak base, okay. So that's prefer SN2 reaction, okay. Right. And if it's kind of strong base and those strong nucleophile, okay, like OH minus, methoxide, ethoxide, okay. So SN2 will compete with kind of the E2, okay, because those can work as both the nucleophile and also the base, okay. Right, and then if it's kind of the weak base but strong, weak nucleophile but strong base, okay. So like T-butyl and also the LDA, okay. So that's LDA, we'll talk about what structure, and also the TA, okay, triazomine, okay, we talk about today, okay. So only E2, okay, no substitution, only E2, no substitution, okay. And if it's kind of the weak nucleophile and the weak base, okay. So normally speaking, just kind of some solvent, okay. So water, alcohol, and also capsic acid, okay, only SN1 and also E1 reactions, okay. So no, don't need recall this species, okay. So just kind of follow my kind of the instruction. I will give kind of a little bit table summary all this kind of the base and nucleophile, okay. Right, so that's you have to keep in mind, okay. So that's first thing you need to calculate, and then second you need to kind of substrate, okay. So substrate case, so if it's kind of methyl substrate case, so like methyl chloride, okay, or kind of methyl chloride, okay, only SN2, okay. So because there's no base hydrogen, you cannot do E1, E2, okay, and also the methyl group case, so cannot do kind of SN1 reactions, okay. So no carbocation, okay. And if the kind of primary substrate, okay, so also kind of the prefer SN2 reactions, okay, okay, and no, again also no SN1 and also E1 reactions because there's kind of no stable carbocation, okay, for the primary substrate, okay. And so if you want to do elimination, only possibility use kind of very bulky base, okay. So strong base but weak nucleophile, okay. So that you can do kind of the E2 reaction for primary substrate, okay. That's only situation, okay, to do kind of the substrate, substitution reactions, okay. Right. So example showed here, okay. So we have this kind of terminal kind of bromide, okay. So normally speaking, only SN2 reaction, okay. But if you use kind of bulky base, okay, so like here this butyl side, okay, so you get kind of E2 elimination product as kind of major product, okay. All right, so now we come kind of the most difficult situation of secondary substrate, okay. Secondary substrate case, you can have both have all four possible reactions, SN1, SN2, and E1, E2, okay. So in this case, you have to look at kind of the nucleophile, okay. So if it's kind of good nucleophile but weak base, okay. So like these guys, okay. So those guys, okay. So that's you have kind of SN2 reactions, okay. And if you have kind of the strong base, no matter kind of the good nucleophile or not, okay. So you have kind of E2 reactions, okay. Okay. And for the SN1 and the E1 reactions, okay, so the only you have kind of weak nucleophile, weak base, okay, so normally kind of neutral conditions, okay. So solvolysis, okay, so solvolysis means kind of the solvent, okay. Okay. As kind of the base or nucleophile, okay. Right. That's called kind of solvolysis, okay. So only this the neutral the solvent, okay, so like here the methanol, okay, or kind of ethanol, okay, or maybe sometimes the water, okay. So those you can have kind of solvolysis, okay, so S1 reactions, okay. Right, and then here's kind of here shows you one kind of solvolysis reactions, okay. So we have kind of secondary kind of here substrate, okay, and then that's ethanol weak base, weak nucleophile, okay. Cannot do S2 reaction and the E2 reactions, okay. Right, and then that's possibility kind of S1 reactions, okay. So right, so S1 reaction for that, okay. And just keep in mind, okay, so quite often the E2 will kind of also product also form kind of coexist with kind of S1 reactions, okay. Right. Right after this water, okay. So this is water, okay. H2O, okay. Can S1 even happen that? No. Allylic, benzoic. Possible, yeah. That's right, okay. Possible, okay. So if you have kind of allylic and benzoic primary substrate, okay, so you can do S1 and also the E1 reaction. That's possible, okay. Because those can generate kind of stable carbocation, okay, even primary, okay. Yeah, that's a good question. Right, and then for the tertiary substrate, okay, and so keep in mind, okay, so there's no SN2 reaction, okay, because two steric hydrogens, okay. And E2 will be kind of pretty favorite, okay. So and that kind of strong base can do E2 elimination for the tertiary substrate, okay. And also the S1 and also E1 reaction is possible, okay, because they can generate kind of more stable carbocation, okay. So right. So here's show you kind of the E2 elimination, okay. So we have kind of very strong base, okay. Very strong base, and then this is kind of the tertiary substrate, okay, and then the E2 product, okay. And here showed you kind of the tertiary substrate, okay, and then weak base, weak nucleophile, and then in this case, S1 and also E1 will be major product, okay. So that's S1 and also E1, okay. All right, okay. So that's two situation, okay. So you have to consider, okay. So the substrate and first nucleophile and then second substrate, okay. And then third situation, you have to think about kind of the temperature, okay. Okay. So normally speaking, okay, a little bit, okay. Yeah, if you have kind of the higher temperature, okay, T, okay, higher temperature. So we'll prefer kind of elimination reactions, okay. Prefer elimination reactions, okay. So E1 and E2 will be kind of become favorite, okay. Yeah. So why is that? Okay, so because that's related to kind of the free energy calculations. Okay, so delta G equals kind of delta H minus T delta S. Okay, so so if you for the SN2 reactions, okay, SN2 reactions that's no delta S change, no entropy change. Okay, so SN2 reactions. Okay, so you have kind of substrate, okay, and then plus nucleophile, okay, and after reaction, you generate kind of still two species, okay, in group, okay, minus here, okay, two species, okay, no, entropy change, okay, no entropy change, okay, so that means kind of the substitution reaction kind of last sensitive kind of temperature, okay, but for the elimination reactions, okay, it's kind of more sensitive to kind of temperature, okay. Reason for that kind of you generate kind of more species, okay. So you start with kind of the two species, kind of base and also substrate, okay. And after reactions, okay, actually you generate kind of three species, okay. So one's alkene, and plus the leaving group, okay, and plus the base pick up the base pick up kind of the base hydrogen, okay. So you have three species, okay. So you increase kind of kind of the entropy, okay. So you have kind of more positive here, okay. Okay. So that means kind of if you increase temperature, okay, So if you increase temperature, okay, and then that's delta Ts will kind of increase, okay. So delta Ts increase, and then delta G will out of your screen decrease, okay. Delta G decrease, okay. So free energy going down. That's preferred kind of for the reactions, okay. So that's here, okay. So elimination reaction has a larger entropy change, okay, and then so the temperature increase kind of favor, okay. Emission is some. Elimination is kind of elimination, okay, not emission, okay. So elimination, okay. So sorry, okay. So if I say emission, okay, so that's wrong, okay. Should be elimination, okay. Elimination, okay. All right. So for you guys, just remember, okay. So if I show kind of temperature, okay, higher temperature, okay. So higher temperature, okay. Sometimes I show like this way, okay. Use some kind of triangle, okay. So that means heat, okay. So that means kind of you have to consider maybe kind of I want you draw kind of elimination product, okay, elimination product, okay, right. Okay, so that's something keep in mind, okay, and there's one example showed here, okay, so at 45 degrees, okay, so you see kind of elimination and substitution product almost 1-to-1, okay, but once you increase the temperature to 100 degrees, okay, so elimination product become kind of a major product, okay. All right. And then in the end, okay, so 3, and then we go here, okay, 4, okay, so you need to look at kind of solvent, okay. Okay, so for the SN2 reaction, we know that kind of like a polar aprotic solvent, okay, like DMS, DMFO, okay, acetone nitride, acetone, okay. And then E1 and also SN1 reaction prefer kind of polar protic solvent, okay, so like water, ethanol, and methanol, okay, because those can stabilize both the Lim group and also the carbon cation, okay. And solvent, okay, priority has kind of less effect on the E2 reactions, okay. So that's just talk about it, okay. So so in this case, when I ask kind of the draw product, okay, so you need to determine SN1, SN2, and E1, E2, okay. So follow this order, okay. So first, look at kind of the nucleophile substrate, okay, followed by kind of substrate, nucleophile, and also base, and then next look at the substrate, and eventually look at kind of temperature and the solvent, okay. So that should be enough for help you determine kind of whether it's kind of SN1 reaction or SN2 reaction, okay. And then some other considerations, okay. So no matter SN1, SN2, and E1, E2, okay, all are required kind of Gooding group, okay. So if you're kind of pooling group, okay, like OH or kind of OR, okay, so you have to think about how do we convert this pooling group into Gooding group, and then do these reactions, okay, all these reactions, okay. And also, be careful with be careful about kind of rearrangement, okay. So only happen to kind of S1 and also E1 because those two kind of carbon cation, and carbon cation you can kind of one to active shift, one to hydrate shift, can give kind of more stable carbon cation, okay. And stereochemistry and also regiochemistry, okay. So stereochemistry, S1 kind of lose the stereochemistry reciprocally, SN2 kind of inverse the stereocenters, okay. And also the E1, okay, so lose stereochemistry, okay, you can generate kind of both cis strands, okay. E2 anti-coplanar, okay. And if it's cyclohexene, okay, so it should be kind of we call kind of trans diaxial conformations, okay. Regiochemistry, okay, so there's no regiochemistry for the S1, SN2, okay, because there's kind of has to be kind of replace kind of Lim group, okay. And the E1, E2, okay, so follow Zansif, okay, that kind of more stable kind of more substitute alkenes, okay. And so this practice we can do it kind of in next kind of the class, okay. And so there's still a little bit time, okay. So any questions, okay, before I close the class today? Quiz tonight only chapter 8, okay, substitution, okay, so it will be very safe, okay. So no elimination, okay. The practice quiz not graded, but eventually once you're done practice, okay, should show you some kind of the percentage grade, okay. So you can take a look, okay? So yeah. No, practice quiz only for you kind of the practice, okay? So only the real quiz tonight, okay? So we'll add into kind of your total grade, okay? Yes, okay. So yeah, multiple times kind of the open for some question of the practice quiz, okay? Like back into drawing question and also some kind of reaction drawing questions, okay? So, but for the multiple choice question, okay, you have only one attempt, okay? Oh, so I already changed the setting of your practice quiz. Okay, so as long as you get the right answer or kind of you finish all the attempts. Okay, and then the right answer will show up. Okay, yeah. So pretty much for example multiple choice question. If you get wrong answer, okay, immediately kind of right answer will show up. Okay, but for magnetic drawing questions, okay, if you draw try 3 times, okay, still get the wrong answer, okay, so right answer will show up. Okay. Yeah, but for the real quiz, okay, so no answer will show up, okay, so you have to kind of until even you finish your quiz, okay, so so I probably will tell the answer probably tomorrow night, okay, so you can see it, okay, so after I kind of review all the quiz, okay. Yeah, for tonight quiz, okay, so start kind of 9 until kind of 11:59, okay, so you don't need to start your quiz kind of at 9, okay, you can start kind of 10, even 11, okay, doesn't matter, okay. So the reason to do that kind of I don't want to cause kind of conjunction of the website, okay, so the slow down everyone, okay, so we want kind of a little bit spread, okay. And so I will turn on my Zoom, okay, during this time slot, okay, so if you have any technical problem, okay, so you can log in Zoom, okay, and then let me know, okay, so only technical problem, okay, so you cannot ask me kind of I don't know the answer for this question, okay, so that's I cannot reply you kind of the question for that, okay. Yeah, make sure you get a mouse, okay. Yeah. All right, so if there's no further question, okay, I will stop the meeting today, okay. So I have office hour, okay, just right after this class, okay, and then you can if you have any question, okay, about kind of practice quiz, homework, even lab, okay, you can come to my office hour, okay. All right, okay, guys, see you later, okay.